Finally, we come to the acceleration video. Hopefully you've watched the displacement and distance video and then the speed and velocity video, and now we will try to totally confuse you on the acceleration video. I have the original axis that I used in the first two videos on displacement here, and if you remember some of those, if we looked at velocity, the velocity vector was change in position over change in time, and I could be over here and I could go from here. We'll say that's XF and this is XI, and so I could say that we were at 1, 2, 3, 4, 5 minus 1, 2, 2, and I could say that this happened in 3 seconds to make my math easy. 5 minus 2 is 3, divided by 3 equals 1 meter per second. And so we'd have a velocity of 1 meter per second, and that's positive, so it was to the right. So that means we moved 1 meter to the right every single second. And what I'm showing you here is that now we're going to have a velocity graph on here. And 1 meter per second right here would correlate to being like right here on the graph. So just wherever we are on here doesn't mean that we're exactly the same place right here. So 1 meter per second as our answer would be like right here on this graph. Or if I had turned these around, I had this be XF and this is XI, we would have had negative 1 meter per second, which means we're traveling negative 1 meters every single second. Well, even though on the position we're over here on the positive side of the position graph, negative 1 meter per second would be right here on this velocity number line. So these don't correlate perfectly here. It depends on where we're going to be here. Okay. Good. All right. So let's do this. Let's figure out our acceleration, because now we're going to have an acceleration vector. And whereas velocity was the rate change of the displacement over time, now acceleration will be the rate change of velocity over time. So how much faster you're going to be going each second. So I'm going to have change in my velocity vector over time. And if you remember, the change in velocity was change in position over time. So I'm going to end up with change in velocity. I'm going to have like a VF, a final velocity, minus a starting velocity over time. And so I could put some places here on my new graph here. I could say let's have this be our final velocity, and let's have this be our initial velocity right there. Okay, and let's see, I think I want to undo that and make a new layer here. Okay, so let's see, I'll have this be my final velocity and this be my initial velocity right there. And we'll say that that takes 3 seconds to go from this velocity to this velocity. So it'd be, what is this velocity? 1, 2, 3, 4, 5 meters per second. 5 minus 2 meters per second. Divided by, so that's 5 minus 2. That's going to, and divide that by our time, which would be 3 seconds. So we're going to get 5 minus 2, which is 3 meters per second over 3 seconds. And that's going to equal 1 meter per second. So 1 meter per second, which means every single second, after 1 second, I'm going to be going 1 meter per second faster. So if I started here at 2 meters per second, 1 second later, I'm going to be going 3 meters per second, and then 4, and then 5 meters per second. Sometimes we don't write it like that. We write it as 1 meter per second squared. We kind of combine the two s's there in a single unit. So I'd be going 1 meter per second squared. I'd be going 1 meter per second faster every single second. So what we want to look at here is our initial velocity. Our initial velocity was 2 meters per second, a plus 2 meters per second. A plus 2 meters per second was our initial velocity. And our acceleration rate is 1 meter per second squared. You'll notice that they both have pluses on them. They're both going in the same direction. Okay? They're both going in the positive direction. That doesn't mean that our positions couldn't have been down here in negative originally, but we're going in the positive direction. And whenever your signs, your velocity, your initial velocity sign and your acceleration sign are the same sign, then you will be accelerating. Whenever your initial velocity and your acceleration sign are the same sign, you will be speeding up. And that's what I mean by accelerating, speeding up. Okay, so let's look at another example of that. Let's do this one in red. Okay, so let's say that we have, here's our final velocity, and here's an initial velocity, and we'll say it takes 4 seconds to go from this initial velocity to this final velocity. So if I figure that out, my final velocity is 1, 2, 3, 4, 5, negative 5 meters per second. All that means is I'm going at a speed to the left, negative 5 meters per second, and then I'm going to subtract what's my initial velocity. I have negative 1. So I was going negative 1 meter per second, which means I was going 1 meter per second to the left. And then now I'm going at the end, I'm going 5 meters per second to the left. So I'm going to divide that by, let's see what I say, 4 seconds. 1, 2, 3. I'm going to have to be 4 seconds to make my math come out nice and easy. So I have negative 5 plus 1 divided by 4 gives me a negative 4 over a 4, which equals a negative 1 meter per second. Negative 1 meter per second squared. Sorry. Negative 1 meter per second squared. I hope I did that on that last one too. I better check. Yes, I did. Okay. So I have an acceleration of negative 1 meter per second for every single second. So the problem is what I'm trying to show you here is with the acceleration, you're going to see a negative or a positive, but you don't know. You don't really know right offhand whether or not that means you're speeding up or whether you're slowing down. You need to compare it to your initial velocity vector. So my initial velocity vector here, was negative 1 meter per second. And since the signs are the same on my initial velocity vector and my acceleration, that means I'm going to be speeding up. So I was at negative 1 meter per second, or the better way to say that is 1 meter per second to the left. And then after another second, I was going 2 meters per second, and then 3 meters per second, 4 meters per second, 5 meters per second. I was going faster and faster in the left direction. So speeding up or slowing down, speeding up will mean that the sign on your acceleration rate and the sign on your initial velocity are the same. Or the sign on your acceleration, the sign on your velocity vector are the same. Okay? If they're opposite, if they're different, then you would be slowing down. So let's do an example of that. So let's say that, let's see, how should we do this? Let's say right here is our initial velocity, and our final velocity is right here. Okay, so let's figure this out. So my final velocity is 1, 2, 3, 4, negative 4 minus the starting velocity, which is 1, 2. Okay, and we'll say it took 2 seconds to do this whole thing. So I have -4 minus 2 would be a -6 divided by 2 equals a -3 meters per second squared. -3 meters per second squared is my acceleration. So am I speeding up or am I slowing down? Well, let's look at our initial velocity. Our initial velocity, VI, was 2 meters per second. And you'll notice that the signs are not the same. The signs are not the same. So that means I have an initial velocity that I'm going to the right at 2 meters per second, but my acceleration is to the left at -3 meters per second squared, which means I'm going to be slowing down. So after a second, I'm going to be going -1 meter per second. So after 1 second, I'm going to go negative. I'm going to drop by 3 meters per second every single second. So at 2 seconds after 1 second, I would be down to -3 meters per second. I'm sorry, -1 meter per second. Yeah, so I have 2 meters per second. After 1 second, I should be going -3 meters per second slower. So I'm going to go down to 1, from 1 to 0, and then I'm going to go to -1, which means that this object actually stops. It goes from 2 to 1 to 0, which means it stops, and then it changes direction and starts to speed up. So if the signs are opposite, we are slowing down. But then you'll notice my final velocity, my VF, was -4 meters per second. That means the signs are now the same. My acceleration and my velocity vector is the same direction, which means we would be accelerating. So an example of something like this would be, I mean, you might think of how can this possibly happen with a single object? Well, if we don't think left and right and we actually think up and down, we think up and down, and we are here on the ground, and we take some object and we throw it up, and we could throw it up with an initial velocity of 2 meters per second. Well, so it's going to go up like this, 2 meters per second. Okay? So what's going to happen is it's going, if we have a negative acceleration rate, and gravity is like 9.81, we'll have a -9.81. So it's 2 meters per second. That means that after every single second, it's going to be going 9.81 meters per second slower. So this is going to slow down as it goes up, and then it's going to get to a point on the top where it's not going any velocity at all. It's going to 0. And then it's going to actually turn around, and the velocity is going to start increasing, but in the opposite direction. So as we're going on the first part here, our velocity vectors is positive, and our gravity, or acceleration, is negative. They're opposite signs, so we're going to be slowing down till we get to 0. And now on the back half, our velocity vector is pointing the other way. So our velocity vector originally was pointing up, which was designated as positive, I guess, and down was negative. So up, it was positive. It was opposite signs of our gravity, so we were slowing down. And then we start falling down, or falling towards the negative direction, so our velocity would be negative direction. And because those signs are the same, so the velocity vector sign is the same as the acceleration sign, that means we are now accelerating. So this is an example of how this could possibly happen. It's kind of hard to see how that could happen on plus and minus, right and left. But if you look at up and down, we designate up as positive and down as negative. We have gravity, which is working down, so it would always be a negative acceleration. And if we throw something up, we're going in the positive direction. So our velocity vectors would be positive, our gravity would be negative, they're opposites. So as I throw something up, it's going to slow down until it stops, and then it turns around and comes down the other way, and then the velocity vectors will all be pointing towards the negative direction. So they'll be negative. They'll be the same sign as the acceleration, and therefore this thing will actually be speeding up on the next part. Okay, so let's maybe we should look at one more example here, because that might have been really confusing. This isn't the easiest stuff. Let's say here is our initial, and out here is our final velocity. Okay, so we have 1, 2, 3, 4, 5. We have 5 minus a minus 2. And just to make it easy, we'll say it took 7 seconds for it to go from here to here. 7 seconds. 5 minus a minus 2 would be 7. 7 divided by 7 would equal 1 meter per second squared. There's my acceleration. I'm going to go 1 meter per second faster or slower for every second. So am I speeding up or am I slowing down? Well, my initial velocity VI, was negative 2 meters per second. And you'll notice that that sign is opposite of those. They're opposite. So that means I was slowing down. So I was going negative 2 meters per second, or I was going 2 meters per second to the direction of left. And then after 1 second, I'd only be going 1 meter per second, still in the direction of left. And then after another second, I'd be going 0. I'd be actually stopped. And then after another second, I'd be going 1 meter per second. So after 1 second, I'm going here, negative 1. After another second, I'm actually stopped. After another second, I'd be going 1 meter per second, but you'll notice I've changed directions. So now my velocity is going to be positive. At this point right here, my velocity now would be 1 meter per second, which is positive. And since my acceleration is also positive, at that point I'm speeding up. So at the beginning here, I would have been slowing down. I'd be going 2 meters per second to the left. Then I'd be only going 1 meter per second to the left. And then I'm actually stopped. And then I'd turn around, I'm going 1 meter per second to the right, 2, 3, 4, 5 meters per second to the right. So I am slowing down at the beginning, but then by the final velocity I am accelerating because my signs match. So my sign on my velocity vector and my sign on my acceleration vector are opposite, then it's going to be slowing down. If they're the same, which they will be after the 0, then we're going to be accelerating. So I hope that made some sense on acceleration. I know it's kind of difficult, so you can watch this video as much as you possibly would like.